In these two examples, we are going to be talking about doing inverse trig functions, integrals of inverse trig functions. So part of it's a recognition, recognizing that you have that version, and then us kind of going through the math on it. So we have a cheat sheet for this. So for some of our formulas that we're going to be having this kind of a look to them because we're going to be doing some inverse trig values. That's kind of the focus of this section. So first thing I got to recognize is which situation do I have? I need to do a little bit of rewriting and a little bit of manipulation to kind of put this thing and kind of set it up correctly. So I'm looking at that version is kind of what we have going on right there. Right, I have a perfect square minus some sort of other square. Now it's not just perfectly x squared, so we're going to have to do some sort of a u substitution kind of a thing to help fix that. Right, so let's do a little bit of rewriting. First thing is I'm going to take that dx off of it. And so I'm going to have a 1 over, and I'm going to start rewriting this in this form. So what number squared? Because then that's the number I'm going to be pulling into the inverse. So 36 would have came from 6 squared. So 6 squared. And then minus 4x squared really would have been a 2x that was squared. So my u, in order to write this appropriately, just like the formula, is my u is going to be this. Because I need it to be just x squared, not 2x squared. So I need a u substitution to make that happen. So my u is 2x, my du is 2dx. Divide that over, so it's a 1/2 du equals dx. Oops, and I forgot. I was pulling off my dx off to there. Okay, so let's rewrite it, and then I can perfectly sub in, use the formula. So I'll pull the 1/2 out, and I'm looking at a 1 over square root of 6 squared minus u squared du. Okay, so now I perfectly have the formula. There it is. So I perfectly have that formula, and I can just sub in my pieces. So if I sub in my pieces, I'm looking at, bring this 1/2 down, and then I'm going to have inverse sine of x, which is u, divided by 6. And then we'll pull the x back into it, the original. So we're going to have inverse sine of, again, just a u divided by 6. So u divided by 6 plus c. And then one last version of this is, almost one last, inverse sine. Our u is really 2x. So 2x divided by 6 plus c. And then we will write it one more time, just simplified out. So 1/2 inverse sine x over 3 plus c. And that is how we work through that one. So let's try the next one. So the next one looks a little bit messier. This has a very natural log feel to it. This has a very similar feel to what we just did, right? Inverse sine kind of a feel to it. So we just need to rewrite it and kind of manipulate stuff and clean it up basically to make it work a little easier for us. So let's start by breaking this up because we're talking about a natural log piece and an inverse sine piece. So how about we take this fraction and let's take the 4/3 off of it. And then that would make this a 1 over square root of 1 minus x squared dx minus, and I'm going to treat this totally separate, pull the 3 off of this one to make it a 1 over x dx. All right, so I have a very natural log feeling on this. So if I do the derivative of a natural log, I'm getting a 1 over x dx. So I'm sitting here and I'm going backwards on it. So that's going to be a natural log. So it's just going to be a 3 natural log. And this does not have a 6 on it. So it's exactly the same formula, except I'm just now going to have a 4/3 inverse sine of, back to my formula, my a is 1. So I'm just dividing by 1. So answer is x over 1, and then minus 3 natural log, absolute value of x, plus c. So one last little cleanup is, I don't really need to leave it like that. So let me write it one more time. 4/3 inverse sine of x minus 3 natural log absolute value of x plus c. All right. So that was introducing and doing a couple problems that to have inverse trig problems.